Dear students, let's start a new topic, refining of aluminium by Hoops electrolysis process. This topic from chapter 7 of class 10th in subject chemistry. Let's open your chemistry book and come on the page number 150. Now, this is the apparatus, and this apparatus is also called the Hoop apparatus for the purification or refining of the aluminium from molten impure aluminium. And this is the Hope's electrolysis apparatus. Now the aluminium obtained through the Hall-Héroult process is not a pure aluminium, and that aluminium contains many types of the impurities such as copper, iron, silicon. So the further refining or purification is needed, and the purification or refining is done by the Hoop's electrolysis process. So in the Hoop electrolysis process, the container or this electrolytic cell consists of carbon lined iron tank. This is the iron tank. This is the iron tank, and it is inner lined with the carbon. So carbon lined iron tank, and this tank contains the following three liquids in three different layers according to their different densities. That means the density which have the lighter placed at the top, and the density which have the higher which placed at the bottom in this container. Now on the top layer of this container, the pure molten aluminium is present, or present in the top layer of this three-layered liquid. So the first layer, which consists of the pure molten aluminium, and this pure molten aluminium act as a cathode. Now in the middle layer, this layer consists of fused mixture of fluorides of sodium, aluminium and beryllium, and this middle layer of the liquids behave as a electrolyte. And in the bottom layers, this one is the bottom layers. So in the bottom layers of the liquids, this bottom layer liquids consist of molten impure aluminium. So in this layer, molten impure aluminium present in the bottom layers. Impure because these molten liquids containing copper, iron and silicon as impurities along with the aluminiums in very small amount. So this is called the impure aluminiums, molten aluminiums in the lower. So in the top, on the top layers, pure molten aluminium act as a cathode. Middle layers, the fused mixture of fluorides of sodium, aluminium and beryllium act as a electrolytes. And in the lower or bottom layers, the impure molten aluminiums, which contain some impurities, and that the lower or bottom layers act as a anode. Now when the electricity is passed through these electrolytes, then the aluminium ions, aluminium 3+ ions from the middle layer goes to the top layer, from the middle layer go to the top layers, aluminium 3 plus ions, and are discharged at the cathode as pure aluminiums. So the aluminiums discharged at the cathode in the form of a pure aluminiums. At the same time, an equivalent amount of aluminium from the bottom layer passes into the middle layers. So the aluminium in the middle layers, or aluminium ions in the electrolytes, always in the equilibriums, because same amount of the aluminiums which deposited, which go up to the top in the cathode regions, and similar amount of the aluminiums again fulfill from the bottom regions in the middle regions. So aluminium in the middle regions, that is in the electrolyte, always in the equilibrium. So through this process, the pure aluminiums which obtained at the region of the cathode on the top layer of the liquids, so pure aluminium is removed from the top, and that pure aluminiums has 99.98% purity. So through the Hooke's electrolytic process, aluminium can be purified. Now come on the page number 151. Now the flow chart for extraction of aluminiums. First, he collected the bauxite ore from the earth crust and crushed the bauxite and washes the bauxite ores. After washing, mix the bauxite ore with sodium conc solution of the sodium hydroxide, and then heated the mixtures of bauxite ores and the sodium hydroxides. After heating, the bauxite ore changes into form into the salt, sodium aluminate. Here the NaOH behave as a base and Al2O3 behave as a acid. As you know that aluminum oxide has the amphoteric nature, so sometimes it behave as acid and sometimes it behave as base. So here it behave as a acid. They combine with the NaOH and forms sodium aluminate. Now filtering that solutions, that mixture, and after filtrations, sodium aluminate get in the filtrate, and that filtrate collected in a different containers and cooled down lightly cool down the solutions. After cooling down, and passes into a precipitator, the sodium aluminate get hydrolyzed, and after hydrolysis they form the aluminium hydroxide, and that aluminium hydroxide, which is insoluble in the solutions and get precipitate out, then filter the precipitate of aluminium hydroxide, and that filtrate first wash and then dried the filtrate. After drying, heated the aluminium hydroxide at the temperature 1100 degrees Celsius. After heating, they gives aluminium hydroxide decompose, and they gives the aluminium oxides and release the water vapor. So aluminium oxide obtained through this process, and that process is called the bearer process. And we get the pure alumina Al2O3 through this process, bearer process. Now, reduction of pure alumina through the electrolysis process. So first we add the cryolites and fluorspars in the pure alumina, and electrolysis of the alumina taken place by the process of Hall's-Herold's process. After electrolysis we get the aluminium metal, but that aluminium metal is not the pure. So further refining or purification of the aluminium taken place by the Hoops electrolysis process. So refining of aluminium by Hoops electrolysis process. After refining we get 99.98% aluminium. So this is all about the extraction of aluminium from their bauxite ore.